Welcome back to Breaking Down Storage Tech. Today we're breaking down a smart restock bulk by Ziku and Skizzy and the box display by IAMBOB. And this is a 1.63 million item capacity per item type, along with being a smart restocking, which I already explained, and it is being a bufferless system. So let's get straight into it. So this system, while it was designed by Ziku, I think that's how you say it, and Skizzy, they have the box sorter up here by Acacia. Now, I'll not be breaking down this box sorter because it's quite complex and I don't want to drag the video on. I really just want to get into the slice itself. But I do have a video breaking it down, and if you guys do want to see a rebooted version of that now with my new skills and being able to explain it much better, I would be more than happy to do that for you guys. Now, the keygen is done by Phil Grudinator, and I have broken down a similar keygen. I believe it was in Kizu's bulk storage, but again, I have a whole video on that. I don't want to drag the video on. So if you guys want to see another video, just let me know. So the main thing is the slice right here, and then the box display right here. Now, I think this is probably one of the cleanest bulks ever, especially being a smart restock bulk. So let me just quickly explain what a smart restocking bulk storage is. So first of all, what is a bulk? A bulk storage is basically a regular storage slice. So for example, if I go in here, this one would store lodestones, this one would store netherite blocks. Now, you can obviously change this based on the filters at the top right there, but a bulk storage, instead of storing the item types loose, like in these shulker boxes you can see right here, if I place it down, it wouldn't be loose just like redstone dust. What it actually be is lots and lots and lots and lots of boxes like this stored like this. So you have access to it in bulk, and that's how it stores 1.63 million items, because it's a bunch of double chests full of the shulker boxes of the items. And that's why we use a box sorter at the top, because we're dealing with full boxes. Now, the one drawback of storing this as boxes is if you only need like 32 or 1 or something, then we run into some problems, and that's why we have the box display, which will place a box down just like right here, so that way you can quickly pick out items, and what will happen is it'll break the box once it's empty and replace it from the chest right here, creating a new box for you, or allowing you to pull more items. And that is not the smart restocking thing. The smart restocking thing is that if this chest ever gets empty, let's say if you take out all of these shulker boxes right here, the system will be able to detect that and unlock its own slice to then allow the stored shulker boxes to make their way down and refill the chest right here. So that's how you get a super useful restocking bulk, because otherwise what you would have to do is manually or wait for the system to put an item into the slice or put a box into the slice to unlock it and allow items to flow down. So I think it is probably one of the best features to look for if you're looking for a bulk. But apart from that, let's just get straight into it. So what I'm actually going to do is take a clone of a single slice. Because this is an a-tileable system, I can just take one slice like so, and then extend it all the way here, and then move this out of the way. And you can see that beautiful cross section. And so yeah, let's get straight into it. We don't have to worry about that. We don't have to worry about that. So what's actually happening? So when we're inputting our full boxes into this chest up here, what's going to happen is because this hopper is locked, it's not going to flow, or any of the items are going to flow. So what's happening is we're waiting for an output from this comparator right here. When this comparator powers, what will happen is it'll power this note block right here, updating this observer and this observer only. This then sends a signal all the way down this note block and these observers to push this glass slice down, moving all of this down one. What this does is, because it's still extended up here, the update of this observer won't do anything to power this piston once it's moved down. So the only thing we're actually updating right here is the connection of this observer to this composter, which will obviously depower and allow this block right here to retract from this sticky piston. And this is being quasi-powered. Now, because there's no block here, any signal from these two lines right here will obviously be null and void, allowing this redstone repeater to unpower, repowering this redstone torch, powering the sticky piston, but also unpowering this redstone repeater right here. Now, going first into this signal before we cover this signal, when this powers, it moves all of this slice up. So when this sticky piston extends, this observer won't output anything because it'll be powering this right stained glass right here, but all of this slice gets moved up. Now what we do this for is because next to every single hopper right here, we have a redstone block, and this is keeping it locked to reduce lag. So by moving all of this up in a kind of piston feed tape fashion, we basically move every single redstone block up one and make every hopper next to now a white stained glass, allowing it to be unlocked and allow items to flow through this half of the system. Now, when this redstone block gets moved up, what also happens is it powers this sticky piston right here to extend this white stained glass and move this white concrete powder. The reason we use white concrete powder is so we have a nice and compact, technically 2 block extenders. That way we can switch between a full block, allowing this comparator to take a signal from this composter. And then we also have a white stained glass, or an invisible block, or a non-conductive block, I should say, to allow there to be no current. So when it does get moved up, what happens is this no longer conducts because it's white stained glass next to the composter. Then this barrel will be unpowered, so these both hoppers will unlock. And furthermore, this note block will no longer be powered, allowing this piston to just retract. Note that this isn't a sticky piston, so it will just be the piston moving up. Now the other half of the signal comes from this redstone repeater that we talked about earlier, of it unpowering. And with the specific delay, what will happen is when it unpowers, it'll unpower these 2 hoppers, allowing the items to travel all the way to this chest right here. But what also happens is it unpowers this note block right here, allowing this piston to update, quasi-powering this piston to push this entire stack up. And now because this piston's retracted, because this no longer has power, this entire stack can move up. What we also do is then by powering this note block right here, or unpowering because the redstone block is no longer there, we can move this sticky piston. So this is just for a neat little UI function. So if I take this redstone block away, as you can see, what happens is this just gets moved down to indicate that the slice is unlocked, and we have a nice little UI to say, hey, this slice is being processed, like so. So with this composter still being here, or being moved up actually, this comparator right here will no longer be powering. What then that causes is this block to unpowering this hopper right here. Now keep in mind, this doesn't update this observer right here, because this observer is up here actually, because this sticky piston has been extended, because this whole line has been turned off, allowing this redstone torch to turn on. And then that's how we unlock the slice, allowing the item to travel neatly through into this chest right here. Now, to actually hopper lock the system, we use the keygen from before to control the hopper locking. So what happens is every time this runs an item, it updates this little clock right here. Now while this clock is active, it's turning on and off this redstone torch to send pulses to this powered rail. When it does, what ends up happening is we send a signal through this observer to the iron door to update it, to then power this observer, to then cause a vertical down chain, to then go through all of this observer line right here, to then go through this rail line, and then all of this observer line. Now at the other side, if I go through right here, what happens is it powers this line right here to update this observer, to power this pulse extender right here, to then power this line right here. And that'll be very important in just a second when we go over the box loaders, or the box display, sorry. So what is the signal right here at the beginning, or from this observer going across all the line, is actually doing becomes much more clear if I actually just quickly run a box through the system. If I just chuck this through here to show what the system looks like when unlocked. So obviously all the redstone blocks are moved out of the way, and we can see this line in this position right here. So every time this observer gets powered, we're attempting to lock every single slice. This is an example of dynamic slice locking, because once we load a box into the slice, especially when it's a bulk slice, the chance that we're going to load another box into the slice is quite highly likely. So it's easier to have the slice just stay open until we're done with the processing, which comes from the signal over there, rather than keeping or locking, unlocking, locking, unlocking every time we try and put a new shulker box in. So it just saves us a bunch of time and lag. So at the end of the processing thing, we get a signal right here to send a signal through this observer line to then power this observer and power this block. Now that this slice has been moved down because the system is unlocked, what happens is it's able to power this note block right here, to power this observer, to power this piston right here through quasi-connectivity, which will then push this entire line back up, resetting it. Now, we then use the composter right here to then power this comparator right here to extend this piston back again and run this whole series again. But this time, when this piston retracts, because we can't retract the entire slice with just a singular sticky piston, because that's not how they work, we use an observer right here to then retract and update and power this regular piston right here to push this slice up. When this slice gets pushed up, this observer powers this block, now powering this note block right here, to run this line right here, to power this block, to push this back down, to reset this for the next time we have to unlock or relock the system. It also sends a line through this note block and then this observer to push this piston right here to stack all of this back down, because now this sticky piston is not extended, allowing us to move all of this from this white stained glass up, back down. Now by moving this back down, what this allows us to do is unpower this sticky piston, bring this glass down and allowing this white concrete powder to fall, allowing this comparator to now be powered by this composter and getting this signal processed through to push all of this back down, because this just doesn't get powered when we're unlocked. And by moving this back down, we push this redstone block back. And that's how we've unlocked and relocked the entire system. So let's actually get to the restocking portion, because this actually uses quite a neat mechanic in my opinion. So we have two main signals to consider. One is this comparator taking the output from the direct chest, sending a signal down this comparator line to this redstone dust. But then we also have a signal coming from the hopper above from this comparator to then power this redstone torch right here. Now I'm quickly just going to repower or relock the system, sorry. So we power that. You can see the whole system locked very beautifully. So we have basically this is the main input right here, or this block is the AND gate for those two signals alongside this signal right here telling us there's an item coming in. So this is the AND gate for all of the unlocking going. If this block gets unpowered or moved up, all of this will take place that we just explained to unlock the system. And so where do our inputs come? Well, obviously the input to unlock the slice, because there's an item coming in, is self-explanatory. But where these inputs come in is a little bit more nuanced. So this is a little trick right here. Basically, if there is no item, obviously, what happens is this comparator is off and this still has signal strength 15 coming from this redstone torch. But what happens is if an item comes in here to this hopper right here, this comparator right here will obviously unpowering this redstone torch, allowing this to unlock, and then bring this down to unlock all of this, allowing this hopper mainly, because we know we have items in this hopper and we know we don't have items in this chest. We want to unlock this to allow the items to flow. So that's the first thing. But what also happens that I think is quite interesting is that this happens regardless if it has any fill level below maximum fill level. So even if I'm all the way here, it will still dynamically restock because it knows it's not full. This uses a neat little mechanic of this comparator right here. So if I just quickly go like this, quickly take this out, I'm going to showcase this mechanic. And if you are a little bit astute and notice that I have a lectern and a book and quill, you'll notice that this is for this very moment right here where I'm explaining the signal strengths. So this comparator will always output 0 from this barrel while this signal strength is less than 15. And that's just such a cool little mechanic. So what happens is no matter how I get this, as long as I get this even to 14, as you can see, this will be a signal strength of 14 right here, as you can see on my top tooltip. This comparator doesn't care, it still takes a priority of this barrel. But as soon as we go over to 15, this gets a signal strength of 15, then that begins to overpower the signal coming from the barrel, allowing this comparator to then power. So how that applies is As long as this isn't a signal strength of 15, this will be 0 when this redstone torch turns off, indicating that there's a item in the hopper. So as long as this isn't full and there's an item in the hopper, this will unlock by unpowering this, bringing the comparator down, or the composter down, sorry, allowing this composter right here to unlock, or sorry, unpowering this block in parallel with this hopper being full of items, causing this redstone torch to be unpowered. So unpower, the whole slice unlocks. And that's essentially how the restock mechanic works. And I just think that's a really neat little use of this niche mechanic, and it just fits the system so beautiful. So one last thing to note is once we've actually done that, we will actually get the relocking of the entire system. And this works by the fact that because we're not dependent on this block anymore, what happens is when this hopper eventually gets cleared, or the system gets a full box underneath, or full chest, sorry, what happens is this line will turn back on, allowing the signal to come back here to unpower this redstone torch, allowing this same sticky piston with observer combo to bring back down an update, just like what happened when we caused the signal to come from right here. It'll push this piston to start the whole locking system. And so yeah, you don't have to worry about slices being unlocked if you have to refill your chests. Now, lastly, moving on to the box displays. So the box displays have a little bit of interesting mechanics to them. The main one being that it does not automatically run or place the first box by itself. That's where the line I was talking about earlier comes through. This little glass thing you can see in the bottom, that is the signal to update all of these note blocks if they can, to try and run the system. And I can give you a little taste. If I get a redstone block, if I just place that here and then break that, you can see it will try and fill every single individual slice. And that's where the mechanic comes from, again, pulling from the same thing of locking at the end of every operation. So at the end of every single operation where we've relocked the entire slice, what we then have to do is check all of these, so that way we don't have to deal with automatic shulker dispensing for the first box dispense inside the slice. And obviously in this case it actually worked because we had boxes in here, so we placed the box. Now, aside from the first slice, when we, let's say we actually have a box, I can place that right here, we take a comparator readout from it. So once we have the box placed like so, we take a comparator readout to this line right here to then power this note block, keeping this extended like so. What actually happens when we empty the box is where it gets interesting. So when this comparator unpowers, it'll actually unpower this piston right here, but it's important to note that this isn't actually a sticky piston, so it'll just retract. This will cause an update to this observer right here to quasi-power this piston right here to push all of the stack back right up, which is this glass block and this observer. But at the same time, when this extends, it'll actually update because it will no longer be a full block, allowing this stone brick wall to update because it's no longer attached to a full block. Now this sends two signals through this observer line and this observer line. Covering this line first, it's quite obvious that it just powers this block right here to extend this piston, or the sticky piston, to move the sticky piston right here. Where the other line comes in is this observer right here, powering this line to move this stack of redstone blocks over to the side, to then update this sticky piston right here to power this observer. This then powers this block as well, powering this repeater right here to run the hopper unlocking sequence, as well as powering this sticky piston right here to extend, powering this, or placing the redstone block right here, which will power this sticky piston to zero tick the powdered snow into the shulker box, getting the shulker box stuck in the powdered snow. But at the same time, what happens is it updates this observer to then power this again. Because what happens is this actually runs on a two cycle sequence. So the first cycle is all of this just running, because what happens is we take the signal of the first signal of this becoming disconnected to run the piston to move the piston out to here. You can see right here, and this will be gone. And because it's zero ticked, it stays out there, and then this piston will just be retracted like that. And this powder snow will be into the shulker box, and the shulker box will be an item form. And we use the second tick of this piston becoming a full block again, connecting with the stone brick wall to run the same sequence. But this time, because everything's already there, this piston will just extend normally to connect with this sticky piston. But when this block moves over here, it'll actually extend the sticky piston to pull the powder snow back. And then by using the observer right here with the extra timing of being updated, it'll keep the sticky piston out here longer for enough for this sticky piston to retract and then be brought back. Now, I know that's a lot, and I'm going to go through with you, or I'm going to go through all of that in slow motion in just a second. I just want to cover one last line, or two last lines, sorry. So basically what happens is when this observer powers, it powers this block to run this redstone repeater. Now this goes up to these redstone torches right here and this repeater right here. What we do is we use the 2 ticks here for when this unpowers, it'll unlock these 2 hoppers. But then 2 ticks later, we want to relock the hopper, so we don't have the 8-tick cooldown of this hopper being unlocked and allowing 2 items to go into this dispenser right here, causing what is called, or causing a buffer essentially, and we want this entire system to be bufferless. So we then use the obviously repowering to power this observer, to power this block, powering this dispenser, but that happens after the 8-tick and then the other 8 ticks, so 16 game ticks for the hopper cooldowns to move the shulker box into the dispenser, which is more than enough time for us to break our box. Now the last line is this same repeater powering this block to update this observer to power this redstone, or this piston, sorry, to move these redstone blocks back. This will then update this redstone line to power this observer right here to keep this same power. So that way it has the 2-tick and then the 4-tick. We do the same over here, except with this observer. So we have the 2-tick and then we have the 4-tick, because the observer takes 2 ticks to notice something and then powers for 2 ticks. But that's how we get the little refixing slicing. So what I'm going to quickly do is I'm going to tick freeze, and then I'm going to take all of these items out, and I don't have enough space, which is just absolutely lovely. I'm just going to delete everything. I'm going to take this last item out, tick step 1, 2, and we can see this release. And as soon as this starts to power, it goes on here, and then we have, that's world edit, 1, 2. So we can see this line start to move and this line start to move here, and we should see now this observer coming to life when this gets unpowered. But as you can see right here, we went through this line right here to move the sticky piston to here. As those, we're starting to power this line to power this observer right here. 1, 2. And we have the 1-tick separation of the redstone lamp unpowering, which I forgot to mention. But this gives us our nice pulse right here. And then we see that it's connected back through the block, allowing these 2 observers to update again. So now we'll see here, we're going to power this redstone block as well as update this line, which will zero tick the sticky piston into the shulker box. And we still have the redstone lines here, but we see that now it's extending. This is starting to retract, this has re-extended, and this redstone block is moving back, and everything's starting to reset, and we're pulling. And then now we just wait for the last sequence of this coming back. So we update once again, power again to use this same observer to power this line right here. And we use the second update of the observer like you just saw, and then bring it back. I wasn't the clearest of explanation, but I hope that that slow-mo definitely cleared up a lot of your issues, or any issues that you might have. So as you can see, everything gets reset, power back, and we have another full box. So yeah, that's pretty much the whole system. Now, one last note is that when this does restock the boxes, what will happen is it will actually activate the thing, or the hopper unlocking or unlocking to restock based on the fullness level of this large chest right here. And that's what I think is so special about this system, is because it reuses the same system. In a lot of systems, you have a separate input for the shulker box right here to say, hey, we should unlock the system. But this just uses this really neat little mechanic right here to have everything so compact and so clean, and just run off of the dual input or the dual signals from the hopper and the chest. Because obviously if you're going to restock the shulker box right here, you're going to have to take from the chest. Overall, I think the design of the system is super great. I just really like bulks in general because of the lined redstone blocks next to the hoppers and stuff. I think that's really cool. But the use of glass in the system is quite cool, and it allows for a lot of different build styles, as well as the UI here being super clean. Like you can see this slice right here. You have the tell weather or the item indicator, you have the chest itself, and then you have the shulker box, and that just repeats for the whole line. I think they did a really good job with the design of the system. I really like the hopper restock line that's here, or the box display restock line right here. I think that's really neat. And overall, just a really well done system. I just don't have that many criticisms. Everything runs really efficiently. So yeah, so that is going to be it for today, guys. I really hope you enjoyed, and yeah, thank you so much for watching.